Alright, so for part B here, we're going to be taking g of x and substituting it into its own function. So here we're going to have g of x, that is equal to 2x. So now we're going to substitute 2x into g of x. So g of x is equal to 2x. So now we're going to substitute that in for x. So it's technically g of 2x is equal to 2 times 2x, which is equal to 4x. So this one here will be nice. We know that this one here has a degree of 1. So it'll be a nice linear function there. So now let's create a table of values so we can graph it. And we'll stick with some nice easy numbers there. So let's go with -1, 0, and 1. Substituting -1 in for 4, or for x there, we have 4 times -1 is -4. 0 times 4 is 0, and 1 times 4 is 4. So it's a nice straight line. It's a linear function, so we don't have to graph too many points. So we can space this out. We can even space it out. Our biggest value there goes from -1 to 1. So we can even put number, maybe even 1 right here, and -1 over, should be about right there. Then we can, our biggest value there is 4. Our lowest one there is -4, so we can go up by once for this one. Alright, so when we have x is equal to -1, we had y was equal to -4. When x was equal to 0, y was equal to 0, so it passes through that origin there. And then when x was equal to 1, y was equal to +4 there. And connecting our dots, you guys should use make sure you guys use a ruler. Should be a nice straight line. Let's, alright, that's not going to happen. Let's pull out our shapes there, because this obviously isn't going to happen. Alright, here we go. Alright, so this is our graph, and make sure, let's definitely label our function here. So here we have y is equal to 4x. Okay. So now let's talk about our domain and range. I'm just going to write this over here. So our domain here, if you guys notice, either just by looking at the graph, or you guys can tell from the function, x can be any number there. So we say x is an element of all real numbers. Looking at the range, that one's going to be quite similar there. So we have y such that, if you guys notice, y can be anything from the graph or even from our function. There's no fractions there, so it makes, or any kind of values that give us non-permissible values. So you can say that y is an element of all real numbers. Alright, so that is it for part B. So now let's move on to number 4 here. So this one's a little bit different. So here we're given h of x, and we actually need to determine f of x and g of x. So this one's a little bit different, so it's kind of interesting there. And this one here is of the function f of g of x. So what we're going to do is we're going to look for, maybe we'll let g of x be something, and then we can remove it and see what we're left with. So we'll start with, so we'll have let g of x. And if you guys are wondering where maybe we should start off with, you see it in these brackets, we have x minus 4. That's common in both of those. So suppose we let g of x equal to x minus 4. So if we removed that, replace that with just x, that would mean that f of x would have to be equal to x squared plus 3x plus 4. And if you guys wanted to test it, verify, put it back in. So if you guys were to think about f of g of x, you would substitute g of x, which is x minus 4, into where x is, and you should result with, have that result of h of x there. So that's a little way you can check it. It's kind of like when you guys factor. If you guys expand your brackets, once when you found those factors, you guys should get back to that original function there. But my biggest hint here is if you can't see it right away, try and look for what's in common, and typically they're in brackets here. So that will be your inner function, or that'll be g of x in this case. And then whatever you let g of x, replace that value with x, and that should be your resulting f of x function. Alright, so you guys can get started on your homework. If you guys have any questions, definitely let me know. And so tomorrow will be an assignment, and we'll have a test in a few days there, alright? Enjoy.